So here I want to start with the counting numbers. Okay. Another name for these counting numbers, we might also call them the natural numbers. And together they'll be called this symbol n for the natural numbers. And what they are is, in some ways, it's what you get from 0 or 1. Some people say 1, but let's start with 0 because it'll be convenient for us. And you keep counting. So 1 is defined to be the number right after 0 when you start counting. Okay, so counting is just some process that we use to get all these other numbers. And the assumption is that every time you count, you get a different number. Okay, and so when you count from 0 to 1, 0, you get the number defined to be 1. The next number you count is defined to be 2. Okay, and then we keep counting on. And when we stop at 9, so we define 4 to be the one after 3, or it could be 1, 2, 3, 4 after 0. And keep going, 5, 6, 7, 8, 9. And then once we get to 9, we start trying to be a little bit more efficient with the symbols. And so that's kind of where this base 10 counting idea comes from. But it's just really a convention where instead of making up another symbol completely, we reuse the symbol 1 and 0 to make it a 1 in the tens column and 0 in the units column. Then we go 11, 12, 13, 14. And the principle is that you're meant to be convinced that you can keep counting forever. So you keep, and that's really an assumption that you can keep counting forever. Okay? So what the natural numbers or the counting numbers are a set, which is a collection of things that collection of things that you more or less know precisely, so we know these are different things to each other. Okay, and the entire collection of them is called the natural numbers.